Hey y'all, my name is Ashley and I'm going to be going over how to work an EOQ problem today. This is one of the problems from the Chapter 12 homework, and I thought it would be a great review because it's one of the main topics of that chapter and it's going to be on the final exam as well. So I'll start off by reading the problem. It says Thomas is the purchasing manager for the headquarters of a large insurance company chain with a central inventory operation. Thomas' fastest moving inventory item has a demand of 5,950 units per year. The cost of each unit is $102 and the inventory carrying cost is $11 per unit per year. The average ordering cost is $29 per order. It takes about 5 days for an order to arrive and the demand for 1 week is 119 units. This is a corporate operation and there are 250 working days per year. And then it asks a few subsequent questions after this. The first one being, what is the EOQ? So first of all, we have to decide which formula to use. And so if you go to the formula sheet, you will obviously use the first EOQ formula because otherwise we would be using the production order quantity model, and the problem never mentioned anything about production or manufacturing any items. So first of all, we need to go back through the problem and write down our givens. So it said that the annual demand was 5,950 units, and the price for the goods were $102. The holding cost was $11 per unit, and the ordering cost was $29. It also mentioned the lead time being 5 days, and there are 250 days per year working days. But we probably won't need the lead time, so it's probably just extra information. So as stated before, which EOQ formula would we use? And it was the first one. The Q starred equals the square root of 2ds over h. And so if we plug in the numbers for this formula, we would do 2 times D, which is 5,950 units, times the ordering cost, which is $29, divided by 11. And we would take the square root of that, and the EOQ would be 177.12, and we round to 2 decimal places. And then the next problem in the question asks, what is the average inventory if the EOQ is used? And so this problem is just asking us to take the average of the EOQ that we found above in A. So all we would do for that is take EOQ or Q divided by 2, which is 177.12 as we found in this problem, divided by 2, and again rounded to 2 decimal places is 88.56. And then the next problem asks us to find what is the optimal number of orders per year. And obviously on the formula sheet, we do not have a formula for this, but if we look at the total cost, if we look at the total cost formula, we can see that the setup cost is D over Q times S, where annual demand is divided by Q. So we can see if demand is divided by Q, that will tell us how many times we have to order this. So we would take D divided by Q. And so once again, we would take our given number, which was 5,950, divided by Q, which was what we found in A, to be 177.12. And once again, we round to 2 decimal places, so it would be 33.59 for C. And then the next problem asks us to find what is the optimal number of days in between any 2 orders. So this is where our working days comes into play, the 250 days per year. So we would take our working days divided by the number we found in C, which was the optimal number of orders. So we would take the 33.59 for the denominator. So working days divided by D over Q, or the number we found in C. So 250 working days divided by 33.59 would give us 7.44 days for D. And once again, we round to 2 decimal places. And And the next problem asks us to find what is the annual cost of ordering and holding inventory. And so if we look at the total cost formula, it is just asking for the setup cost and the holding cost. So we would take D over Q times S plus Q over 2 times H, and we would leave the P times D out for now. And so for E, once again, we would use that formula, just ordering cost and holding cost. And once again, we would take our givens and plug those in to the formula, as you see here. So 5,950 divided by 177.12 times 29 plus 177.12 divided by 2 times 11. And then we would get 974.20 plus 974.16. And if we did the EOQ portion of this problem correctly, then these two numbers, the ordering cost and the holding cost, should be very similar as they are here. And so if we add those two numbers up, we would get a ordering cost and holding cost to be 1,948.36, once again, round to 2 decimal places. And the last and final portion of this problem asks us to find what is the total annual inventory cost, including the cost of the 5,950 units. So we have already done a portion of this problem in the last letter E. So previously we found setup cost plus holding cost. Now all we need to do is take that number that we found and add the price times the demand. So we can see here that we have taken the total cost formula and we found D over Q times S to be 974.20 in the last problem, and Q over 2 times H is 974.16. So all we need to do for this problem is take 102, which is the price, times the demand, 5,950, and add it to these two other numbers. And to find the total annual inventory cost, including the cost of 5,950 units, to be 608,848.36.